This lesson is on solving systems using substitution and elimination. So yesterday we would solve this for y and graph both of these and find the point where the two lines crossed. Today I'm going to show you how to find them algebraically, so you don't have to solve for y and you don't have to graph and worry about drawing a straight line. This is an algebraic way to figure out where the two lines cross. You're still finding the same thing. You're going to use substitution anytime you have an x or a y variable by itself. This is what it equals. So x equals a negative 2y minus 2. That means everywhere I see an x, I can substitute this in for it because they're equal. So down here where I see this x, I'm going to take him out and put this in its place. Again, because x and negative 2y minus 2 are equal. So 3, substitute that in, minus 2y equals 10. Now I'm going to distribute. Combine my like terms, so the negative 6y and the negative 2 would be a negative 8y. And so y equals a negative 2. So what you've just found is the y value of your point where the two lines cross. To get your x value, if you'll go back into what you circled, so x equals negative 2, but now in place of the y, I can now put a negative 2 because y equals a negative 2. And so now I know that x is 2. So now that I know what x is and what y is, I know the point where the two lines cross. Remember, it's always x comma y. So these two lines, if I were to graph them, would cross at the point 2, negative 2. But I can do this without graphing. Okay, number 2, again, this is a substitution problem because I have a variable by itself. This time it's a y. This is my substitute because they're equal to each other. So come down here and I'm going to substitute this in for the y. So I'm going to take the y out and put the negative 3x plus 7 in his place. So 4x plus 2, take the y out, substitute that in, and then I just clean. Distribute my 2. Combine my like terms, so I have a positive 4x and a negative 6x. That's negative 2x. Okay, so there's the x. And then I'm going to go back into what I circled and take my negative 1 and plug it in for x. So the point where the two lines cross is negative 110. Okay, number 3, again, this is substitution. This is my variable that's by itself. This is what he equals, so that's who we're going to substitute. So I'm going to find my y, and I'm going to put this in its place. So 3x minus 3, 5 minus 2x. And then 3x and the positive 6x is 9x. Add 15. Divide by 9. And then I'm going to go back into what I circled and plug my 2 in for my x. So y equals 1. So my point is 2, 1. Okay, number 4, again, this is my variable that's by itself. This is what I'm going to use to substitute. So I find my y, and I'm going to plug that in. And then I'm going to distribute my negative 2. Watch your signs. Okay, and then what happens? I have a 12x and a negative 12x, and they are going to cancel and completely cross each other out. This is what I'm left with. I don't have any x's, any y's. This is what I'm left with. Well, if you'll remember from yesterday when we solved them by graphing, we said there were 3 types of solution. Number 1, you could have a point. And number 2, you could have no solution because the lines are parallel. And number 3, you could have infinite solutions because they are the same line. Well, when all your variables go away, it's one of these 2. Don't jump the gun and say it's no solution. You have to look at what you're left with. If what you're left with is a false statement, which this is, 10 does not equal 3, it's a false statement, then we are no solution. But if what you're left with is a true statement, then it would be infinite solutions. So if I happen to be left with 3 equals 3, and that's a true statement, then the answer would be infinite solutions. Okay, elimination. So on this one, when you think of the word eliminate, you think of something's going to cancel. So what I want to do is I want to add these 2 equations together so that a pair of my variables cancel. So if you look at this system, you see that I have a positive 2y and a negative 2y. Well, they are the same, but one's a positive and one's a negative. So if I were to add my 2 equations together, so 1x plus 3x gives me 4x, these are going to eliminate. They're going to cancel. And then a negative 2 and a 10 is an 8. Divide by 4, x equals 2. That's fast. But we're not done. Remember, this is just the x value of my point. So now I can take this x and I can put it here or here. And it doesn't matter, you're going to get the same answer. So you want to plug it into the one that has the least amount of work. So we'll go into the top one. So x is 2. Two y equals, oh wait, that's a negative 2. Negative 4. So your point where the 2 lines cross. And one other thing I want to point out is you've got to be able to tell the difference between when to do substitution and when to do elimination. So this is definitely elimination because you can see that you don't have a variable that's by itself like you did in the previous 4 problems. Okay, number 2, again, this is a system. I don't have an isolated variable or a variable by itself. I do have 2 letters that are going to cancel if I add them together. Don't get used to that. Enjoy that while we've got it, because here in a little bit that's going to change. M plus 2m is 3m. Those are going to cancel because they are exactly the same, but one's a positive, one's a negative. And 6 plus 3 is 9. Divide by 3. M is 3. So I can either plug him there or there. I'm going to go into the top because I think it looks easier. So 3 plus n equals 6. Subtract your 3. N equals 3. And then a lot of people get confused here because I know they're both 3. So your point's going to be 3, 3 either way. The question is which one comes first if it's not an x and a y. And the answer is it's always alphabetical. So M and then N. Okay, number 3, definitely not a substitution problem, and this is an elimination problem, but you'll notice that we don't have 2 variables that are going to eliminate for us. So we have to make it so that something will cancel. So look at your x's. If I got my x's to cancel, what would need to change? What could I multiply by to make them the same? And I could turn them both into an 8x. The top one is fine because he's already an 8x. The bottom one, if I multiplied the whole bottom equation by a positive 4, wouldn't that make this term a negative 8x? And then it would cancel with that term. So that's one option. Another option is look at the y's. If you look at the y's, I have one that's a 1y and one that's a 3y. Well, I can turn them both into a 3y. He's good. But what do you need to multiply him by so that he'll cancel with this guy? And the answer is a negative 3. Now, why has he got to be negative? Well, I need him to be a 3y, but I need one to be positive and one to be negative. And since the bottom one's already positive, we'll slap a negative on this 3 that we're going to multiply by just to change him. Now, you can do either way. You can do your x's or your y's. It doesn't matter. I'm going to go ahead and do my y's since it's already written up there. So I'm going to multiply the whole top equation by negative 3. So negative 24x minus 3y equals a negative 36. And then negative 2x plus 3y equals 10. And you can see that those are going to cancel. That was the whole point of what we did. So now I'll just add everything else up. Well, this is a negative 26x equals a negative 26. Divide. And I got x to be 1. So now I can take my x and plug it there or there. Let's see. Let's go top. So 8 times 1 plus y equals 12. 8 times 1 is 8. So y equals 4. So my point is 1, 4. Number 4. Okay, so we're going to think about this again. If I want my x's to cancel, I have a 5x and a 1x. What can I turn them both into? Now I could turn them both into a 5x. The top guy's fine. He's already a 5x. So what would you need to multiply the bottom equation by so that your x's would cancel? And the answer is a negative 5. If I wanted my y's to cancel, what could I turn both of these into? A 6. Well, what would you need to multiply the top by? A 2. And what would you need to multiply the bottom by? A 3. Well, that sounds much more complicated than the x's. So let's back off of this one and let's go do x's. So to get my x's to cancel, we said a 5. So top equation's good. The bottom equation needs a 5, but not only does it need a 5, it needs to be a negative 5. Because remember, I can't just have them be the same. One has to be positive and one has to be negative. So 5x minus 3y equals 2. And negative 5x minus 10y equals a negative 15. So that would give me a negative 13y equals a negative 13. Divide y equals 1. So I can go either here or here. I'm going to go to the bottom. So x plus 2 times 1 so my answer is 1, 1. Number 5. Again, let's talk x's. If I want to get my x's to cancel, what number could I turn them both into? And the answer is a 12. The top number is already a 12. He doesn't need a thing. The bottom number is a 3. So what does he need to be multiplied by for him to be able to cancel with a negative 12? And that would be a negative 4. So that would be my x's. If I want my y's to cancel, which would be a different process, if I want to get my y's to cancel, I have an 8y and a 4y. Well, I can turn them both into an 8. So I would need to multiply this guy by negative 2. Either way, it doesn't matter. I'm going to stay here and do the y's. So 12x plus 8y equals negative 8. And negative 6x minus 8y equals negative 4. Those cancel. 6x equals negative 12. X equals a negative 2. I can plug it here or here. I'm going to go to the bottom because I think it's easier. So my answer is X, Y. Okay, number 6. If I want to get my x's to cancel, I have a 6 and an 8. You've really got to know your multiplication facts to be able to figure this out quickly. So what will a 6 and an 8 both go into? Well, they will both turn into, let's see, I can't go 16 or 18. I can go 24. I can turn them both into a 24. So if I multiply the top by what to become a 24? He would need a 4. And the bottom would need to be multiplied by what to become a 24? And that would be a 3, and one of them would need to be negative. So that's one way you can go, and that would be perfectly fine, absolutely fine. I'm just going to show you with the y's, just so you can see it again with the y's. So I have a 3y and a 5y. What can I turn the y's into so that they'll cancel? So I have a 3 and a 5. I can get them both up to a 15. So what do I need to multiply him by to become a 15? And that would be a 5. And what do I need to multiply him by to become a 15? And that would be a 3. Unfortunately, that would give me two positive 15s, which would not cancel. So one of these two numbers needs to be negative to make somebody cancel. Now, my options were with the x's a 24 and with the y's a 15. I'm going to go with the 15 just because it makes my number smaller. So I'm going to stay right here with this. So the top equation I'm going to multiply by 5. So 6x equals negative 6. Okay, then I can go here or here. I'm going to go to the top because I think the numbers are smaller. So 6 times negative 1 plus 3y equals 6. So negative 6 plus 3y equals 6. Add 6. 3y equals 12. Y equals 4. There you go. Okay. Next problem. Let's see. If I get my x's to cancel, I could turn them both into a 9. The top equation is fine. The bottom equation would need to be multiplied by a negative 3. If I want my y's to cancel, I could turn them both into a 12. Again, the top is fine, and the bottom would need to be multiplied by a negative 3. All right, so let's multiply the bottom by negative 3 and see what happens. So the top equation is staying put. The bottom equation is getting multiplied by a negative 3. What happens? The x's cancel and the y's cancel. Well, do you remember our three solutions? We have a point, we have no solution, and we have infinite solutions. We said point, those are all the ones we've been doing. This is when you get a false statement, and this is when you get a true statement. So let's look. On this side of the equals, I have a 0 because everything cancels. And on this side of the equals, I have a 9. That is definitely a false statement. So this is no solution, which means these two lines, if I were to graph them, would be parallel and never touch. Okay, last problem. So if I want my x's to cancel, I'm going to turn them both into a 10. So multiply the top by 5. It's already got the negative. Just needs a 5. If I want my y's to cancel, I would get them up to a 20. So again, I would multiply the top by 5. So either way, we're multiplying by 5. And then I slide the bottom equation back up under. And then you can see it. These are going to cancel and these cancel. So I have 0 equals. The question is, what happens on the other side? Well, these 10s also cancel. So I get 0 equals 0, which is a true statement. So this is infinite solutions.